So hello everyone. So in the last video, we learned how to create a geometry using design modeler by reading the coordinates. So in this tutorial, I will be going through how to create the mesh for NACA 001 to airfoil. So if you see, initially we had this question mark in the meshing one, but when we created the geometry, it changed to this lightning symbol. So in order to do the meshing, what you have to do is you have to just double click it and your meshing will be done. Meshing interface will be loaded. So I have already loaded it here. So once you load the meshing thing, it will look something like this. If everything is perfect, you will get the green arrows in geometry, material, coordinate systems everywhere except meshing because till now we haven't done any meshing. If something is wrong, then you will get some arrow or like some cross sign or some question mark. It means there is some error in your geometry. So you have to see what is your error and you have to go back to design modeler and resolve it. So in our case, everything is fine. So we can proceed to meshing. So in order to do meshing, so click on meshing. And the first thing which you have to make sure is this physics preference should always be CFD. Sometimes by default it is mechanical or non-linear mechanics, something like that. In that case, when you try to generate mesh, in one of the phases the mesh won't be generated and you won't able to figure out that easily, like what is the issue. Everything seems to be correct, so make sure it is CFD. So in this case you won't get any difficulty ever. So this happened with me earlier. So that's why make sure first thing which you have to make sure is physics preferences CFD. Now, if you remember, we created this six different phases, and the reason why we created this is because we want to map these three edges together. We want to map these two surfaces of the airfoil with these two edges. Similarly, we want to map this front edge of the airfoil with this curved surface and this edge with this curved surface. So let's do it. So first what we have to do is make sure you select this option, which is the edge option. By this, you will be able to select all the edges. If you are in this option face, you will be able to select the face. Similarly, this is to select the entire body. This is to select the points. So you want to select the edges. So make sure you have activated this edge option. Then right click on mesh, insert and sizing. If you want, you can just select all these three edges and then you can insert sizing. Both will work. Now in the geometry, we want to select these three edges. So again, to select multiple edges, click Control and select all of them and then click Apply. Next, you have to go to type. So right now the type is element size. So if you want, you can mesh it according to element size also, but I prefer number of divisions. So I have selected number of divisions. So let's say the number of division is 100. Again, how 100? It will, again, here you have to do a little bit of analysis by yourself. First, you will do some meshing. Then you will run some simulation, look at your result. If it is not good, you will come back, refine your mesh, and again run the simulation. So it's a kind of trial and error method which you have to do again and again in order to find out what is your optimum number for number of divisions, optimal number for bias type and all those stuff. So for this tutorial, I will be creating a very coarse mesh, not very fine mesh. So that's why I'm going with 100. Then you have to just uh, click, make sure this cap, capture curvature should be no. The reason for this is because we want to change our behavior from soft to hard. Why it is important to change from soft to hard? Because if you let it be soft, then during the sizing option, S sizing, if NC Fluent is able, let's say you mentioned that you want 100 edges or 100 elements near the edge, and if NC Fluent is able to do only 80, it will do 80, but if you select 100 hard, then it will force the NC Fluent will to generate 100 elements near the edge. So make sure your behavior is hard. So now you can see I have this 100 elements. This edge has been divided into 100 different elements. So right now all the elements are equally spaced, but we are more interested towards, we are more interested what happens near the airfoil. We are not interested what is happening like very far, like towards this right edge and all, because we are not going to capture any flow property there. So that's why we want all our elements to be concentrated near the airfoil. So in order to do that, you will use this option called as bias type. So right now we don't have any bias, but we want to make all the cells to be concentrated towards the leading edge, sorry, the trailing edge of the airfoil. So we will activate this bias type and we will select this second option. So you have to mention here bias factor. So let's say 200 again. This is something which you have to figure it by yourself by running multiple simulations. And then so if you see here, this edge is okay because we have high concentration of elements towards the leading edge. But if you look at the other two edges, you can see here we have high concentration away from the leading edge, trailing edge. Same happened here. So we want to reverse the bias in these two. So again, by using control key, select these two edges and then click on apply. So you can see they have reversed. Now everything looks correct. So this is okay. Now next step is mm, we want to map these two surfaces with these two surfaces. So let's do that, or let us first map all these 6 vertical lines. So again, right click, insert sizing, and this time select again all these vertical edges like this. Click on OK. Again, type should be number of divisions. So let's say 200. 200 is too much. So let's say 100. Again, you have to play around with this number to see which number works best for you. Again, make sure your capture curvature should be no and behavior should be hard. For the bias type, again, I will go with this one, bias factor, let's say again 200. So everything seems to be correct, good, but except these 3 edges. So here I have to apply reverse bias. So select all these 3 edges and then click on apply. So you can see now everything seems to be good. Now again, right click, insert sizing. So we want to this edge, again control, this this edge, this edge, and then zoom out. So this edge and then this edge. So these 4 edges. Again, here it should be number of divisions. Now this is very small edge. I don't want very high number of divisions. So I think 80 will work. Let's see. So 80 is too much. So let's say 50. Again, capture curvature should be no. Behavior should be hard. And we don't want any kind of bias here. Now the last thing which we have to do is insert sizing. So we want to map these 2 edges with these 2 curved edges. So apply. Again, type should be number of division. In this case, 20 will work because remember this is very small. Okay. So again, capture curvature from yes to no, behavior hard, and again, we don't want any bias. So after doing all the S sizing, the next thing which you have to do is you have to do the face meshing. So right click, insert face meshing and select all the faces. Then click on apply, leave everything as it is and make sure your method should be quadrilaterals, not some triangles or something because we want to create quadrilateral mesh. And once everything is done, you can right click and you can click on generate mesh, or you can click here also generate mesh. Both options are same. So you can see my mesh is getting generated, and you can see my mesh is generated. And remember, whenever you get any kind of warnings or something in ANSYS Fluent, you don't have to ignore it. You have to make sure you address that. So right in this case, we didn't get any error. It's a kind of warning. So if you want, we have to, if you want, you can ignore it because it's just a warning, not an error. If it would have been error, we need to definitely correct this before moving ahead. But since it is warning, if you want, you can leave it. But if you not, you have to address it. So you can see it is related to defeaturing. So let me go and turn off the defeaturing. So to get that option, click on mesh and click on sizing. So you can see here you have this option mesh defeaturing. So make sure you to select no, and then let me update mesh and see whether I'm getting any errors or no. And if you want, and yeah, you can see here my mesh has been generated successfully and there is no error at all. So it means my mesh is good. And if I zoom in, so you can see this is how my mesh looks like. So again, make sure it's like if you see here, this is not a good mesh because you can see here the size of this element is very small and suddenly the size of element became very big, which we don't want. So if you want, you can go back to S sizing 3 and change it from 50 to let's say 80. And then again, you can regenerate the mesh. So now if I zoom in there, so now you can see it's pretty not that perfect, but yeah, pretty better as compared to previous one. It means I have to increase it more. So I'm not gonna do all these things in this tutorial because the main aim of this tutorial is to make you familiar with all the things which you have to do, not to get the optimal result. And if you have seen, I have concentrated all the elements for the vertical edges near this airfoil. This allows me to get this kind of, you can see a kind of inflation layer near the airfoil. Now, what do I mean by inflation layer? So if you see near the boundary of the airfoil, we know that boundary layer is going to be generated. So we want to capture that phenomena of boundary layer. So we want more number of cells near the boundary of the airfoil. So that is kind of inflation. So if you want to get more inflation, you can increase the number of nodes or the number of elements near the airfoil surface. Again, by playing around with this number of divisions and all those stuff by number of bias factors. But yeah, for this tutorial, this mesh looks perfectly good. We can go ahead with this. Now, before moving ahead for the setup part, one more thing which you have to do here is you have to name the boundaries. If you forget to do it, you can do it in setup part also, but it's a little bit complicated way to do it in setup part. So it's better to do it in meshing only. So I want to, so first let me select edges and I want to select these edges and I want to name them as inlet. So the shortcut is N. Press N in your keyboard. So this will appear. So just type inlet. Then I want to give these two edges outlet. And then I want to keep these two as airfoil top surface. And I want to keep this one and this one as airfoil bottom surface. So if you want, you can keep all these four regions, one name as airfoil boundary or something. The reason why I separated top surface and bottom surface, because there can be some, there are some properties which we want to like plot just for the airfoil top surface. There are some plots which we want to do just for the bottom surface for that. So now if you go back to your name section, so you can see, you can confirm what is your inlet, your outlet, your airfoil top surface, airfoil bottom surface. If something you are missing or something, you can rename it or you can add that missing edge there. So that's all what you have to do in the meshing part, and make sure after the name section you click on update mesh so that your mesh will get updated. Yeah, that's it. See you in the next one. Thank you.